Cambridge IGCSE, May-June 2021, 0625, paper 21. Question 1. The diagram shows a stone of irregular shape. Which property of the stone can be found by lowering it into a measuring cylinder half filled with water? So here we have to think with a measuring cylinder which consists of some water, and as shown in the figure here we have a measuring cylinder with 100 ml of water. In order to measure the volume of a irregularly shaped stone, if you have a irregularly shaped stone and if you need to calculate the volume of this stone, what we have to do is we have to put this stone inside the measuring cylinder. So the water level will increase because of the volume of this stone, and we can check what is the new measurement of volume. Suppose the new measurement is 130 ml. The volume of this stone will be final volume minus initial volume. So we will get 30 milliliter, or okay, so that is the volume of this stone. Therefore here the answer is, which property of the stone can be found by lowering it into a measuring cylinder half filled with water? So we can find or measure the volume of the stone using this method. Part 2. Which law describes speed and velocity? So speed is a physical quantity which has only magnitude. We don't have to mention the direction, so that is a scalar quantity. Whereas velocity is a physical quantity which has both magnitude and direction. We should mention the direction also, that in which direction that object is moving. Therefore, velocity is a vector quantity. So by looking at the option, we can see speed is scalar and velocity is vector. Therefore, the correct answer is option B. Question 3. 4 balls with different masses are dropped from the heights shown. Air resistance may be ignored. Which ball has the smallest average speed? So here we have to see, we are provided with 4 different balls with different masses. But we need to check what will happen to their average speed. So here one important thing we need to know, that the mass of an object is not going to affect the speed when it is falling towards ground, especially if there is no air resistance. So we don't have to look at the mass. Mass is not going to have any effect on average speed of an object. The reason for this is, if you have an object, it can be a ball or any object, which is falling freely under gravity. Here all balls are moving in the same way. There is no air resistance. So the only force acting on the ball or the falling object is its weight. So the only force acting on the ball is its weight. So we can write the only force or the net force is the weight of the object. And we know the equation of force, that is ma, and equation of weight is mg. Now look at the equation where mass is common at both sides, so we can cancel. So we will get the acceleration or the amount of increase in speed only depend on the g value. So where g is nothing but the acceleration due to gravity or gravitational field strength, and that value is 10 meter per second for Earth. So from this we can understand that for any free falling object, its acceleration is always 10 meter per second. Doesn't matter how heavy the object is. So the mass is not going to affect on the acceleration. Now we can check the second factor in the given scenario, that the height falling is different. Now we can check, is there any effect on average speed and height for a free falling object? And we have already seen all these free falling objects will accelerate. That value is equal to g, that is 10 meter per second. So the acceleration is there. That means the object which is falling is keep increasing its speed every moment. That means when more height it has to travel, means more time to increase the speed, as there is a constant acceleration continuously. So the height is more for an object, the speed or average speed will be more. Therefore, we can conclude that for the ball in option D is traveling a maximum distance, so it will have a maximum average speed. Likewise, the first ball is traveling the least distance, so it will have a least or the smallest average speed. And in the question we need to find which ball has the smallest average speed. Therefore, the correct answer is option A. Question for an object of mass 2 kg is taken from the earth where the gravitational field strength is 10 Newton per kg to the moon where the gravitational field strength is 1.6 Newton per kg. Which row is correct? Weight on earth and weight on moon, both we need to calculate here. So we are provided with the mass of the object, that is 2. So we can calculate the weight of the object on earth will be, the equation of weight is W is equal to mg. We can use the same equation. So weight on earth will be m times gravitational field strength on earth. So mass is 2 times gravitational field strength on earth is 10. So we will get 20 Newton. Likewise, we can calculate the weight on moon using the same equation mg, but where the g is the gravitational field strength of moon, and that is m is 2 times gravitational field strength on moon is 1.6. So we will get 3.2 Newton. Therefore, the correct answer is option D, where the weight on earth is 20 Newton and weight on moon is 3.2 Newton. Question number 5. The mass of an empty flask is 34 gram. The volume of the liquid added to the flask is 20 centimeter cube. Total mass of the flask and the liquid is 50 gram. What is the density of the liquid? So we have to calculate density. Here we can use the equation of density, that is mass over volume. So density of liquid we need to calculate. So the density of liquid will mass of the liquid over volume of the liquid. So we need to check or find out what is the mass of the liquid and what is the volume of the liquid from the question. So initially we had an empty flask and its mass is given, that is 34 gram. Later the flask is filled with a liquid. So the new mass or the total mass of the flask and the liquid is 50 gram. So we can measure what will be the mass of the liquid here. So mass of liquid will be the difference of the total mass of liquid and the flask, that is 50 gram, minus the mass of the flask. So we will get 16 gram. So that is the mass of the liquid. Likewise, the volume of the liquid is directly given, that is 20 centimeter cube. So we have volume. Now we can substitute these values in the equation. So mass of liquid is 16 gram over volume of liquid is 20 centimeter cube. And using the calculator we can find the answer, and that is 0.80 gram over centimeter cube. Therefore, the correct answer is option A. Question 6. The extension load graph for a spring is shown. The unstretched length of the spring is 17 centimeter. So we are provided with a extension load graph and the original length is given, that is 17 centimeter. When an object is suspended from the spring, the length of the spring is 19.2. So the new length is also given. What is the weight of the object? So we need to find out what is the weight which we have hung on the object in order to have a new length of 19.2 centimeter. So we have to basically find what is the weight or load or force. So first of all, we have to check the extension of the spring. So initial length of the spring is given, the original length. It was 17 centimeter mentioned in the question already. So that was the initial length of the spring, but there was no load. But when a particular object suspended on the spring extended, and as the spring extended, its length increased, and a new length is also given in the question, that is 19.2 centimeter. So we can find the extension of the spring or how much the spring extended just by subtracting the new length, that is 19.2 minus the original length or the old length. So we will get 2.2 centimeter. So this is the extension of the spring. So now we can use the graph. We can check for an extension 2.2 what will be the value of corresponding force or load. So let's check the graph where 2.2 is this point and corresponding value on x-axis or the load value on x-axis we can see, and that is 3 Newton. So we just need to check the extension. Once we calculate the extension by subtracting the new length minus original length, look at the graph and find the force value corresponding to this extension. So the load is 3 Newton. Therefore, the correct answer is option D. Question 7. A cart has a mass of 10 kilogram. Mass is given. A boy pushes on the cart horizontally with a force of 50 Newton. The cart accelerates at 0.50 meter per second. What is the frictional force acting on the cart? So here in this question we have a cart with a mass of 10 kg and which accelerates, and the acceleration is also given 0.50 meter per second square. So we can find for this mass and this particular acceleration what will be the net force acting on the cart in order to have an acceleration of 0.50. So we can use the equation. The net force on the cart must be mass of the cart times the acceleration of the cart. So we have the mass, that is 10 times acceleration is 0.50. So we will get 5 Newton. That means there is a resultant force of only 5 Newton is acting on the cart in order to have an acceleration of 0.50. But in the question it's mentioned that a boy pushes on the cart horizontally with a force 50 Newton. So there is a boy who is pushing on the cart with a 50 Newton force, but on the cart the net force is only 5 Newton force. So what happened to the remaining 45 Newton force? As the boy is pushing the cart with a 50 Newton force, even though he is applying a 50 Newton force, only 5 Newton force is resulting on the cart. So what happened to the remaining 45 Newton? So that means we can understand this 45 Newton force has used against frictional force, or it must be wasted to work against friction. So the correct answer is 45, option D. Question number 8. A ball has a mass of 2 kg. The ball approaches a wall at speed 3 meter per second and rebounds at a speed of 1 meter per second. What is the impulse on the wall? So we need to calculate impulse, and we are provided with the mass of the ball and its initial speed and final speed. So we have mass, that is 2 kg, and initial speed or initial velocity we can represent it with u, that is 3 meter per second, and after it rebounds its velocity decreased, as we can see, and that is final velocity is 1 meter per second. But we have to understand, when we consider velocity, initial velocity of the ball directing towards left, but the final velocity or after rebounds the ball directs towards right. So their direction changes. So initial velocity, if you consider as positive, the final velocity as it's moving in opposite direction, we should consider as negative. So now we have mass, initial and final velocities of the ball. And in order to calculate impulse, you should know two equations of impulse. The first equation is the basic equation of the impulse, that is impulse is force times time. And the second equation that you can derive from the equation F is equal to ma. Anyway, you need to by heart the second equation of impulse also, that is nothing but change in momentum. Or we can write change in momentum means final momentum of the ball minus initial momentum of the ball, mv minus mvu. So impulse is equal to change in momentum, that is mv minus mvu. So we have these two equations for impulse, but in this particular question, as we are provided with the mass and initial final velocities of the ball, we can use the second equation of impulse, that is impulse is mv minus mvu. So we can calculate by substituting the values, where mass is 2 times final velocity is minus 1 minus again mu, 2 times initial velocity u is 3. So we will get minus 2, that is 2 into minus 1 is minus 2, minus 2 into 3 is minus 6. Therefore the correct answer is minus 8. And as it is impulse, the unit of impulse is, look at the equation of impulse. Impulse is force times time. So the unit of force times unit of time, that is unit of force is Newton times the unit of time is second. So the unit of impulse is Newton second. So our answer is 8 Newton second. We don't have to put negative sign, as negative sign here we are using simply to indicate the direction. So the final answer is simply 8 Newton second. Therefore the correct answer is option D. Do not confuse with option C, as the value is correct, or the magnitude of the answer is 8, which is correct, but when you look at the unit, it is simply Newton. Newton means it must be a force, but here you are calculating a impulse, so the unit must be Newton second. Therefore the correct answer is only option D. Question 9. Which situation involves no work being done and no energy being transferred? So we have to check in which situation given in the options work has not been done, no work done. So before going to the options, let's check what is the condition for a work being done. So the equation of work done is force into displacement or distance moved by the object. So we can say when a work has done only if there is a force acting on the object, and because of that force the object should displace or move in the direction of the force. For example, if you have a box and if you apply a force F on this box, and because of this force, if this box is displacing or moving some distance, so we can see the force has applied, and because of the force there is a displacement also happened. The box has displaced. In this case the work has done. So two important conditions for a work to be done is there must be a force and there must be a displacement. So let's check each options. Whether they satisfy these both conditions, then we can say the work has done. So option A says a car skidding to a stop on a road. So there must be a frictional force, and car is skidding, that means the car is moving. So both conditions satisfy here. That means in the case of option A, work has done. So the A is not correct answer. Let's look at option B, a crane lifting a load. So in order to lift there must be a force applied, and its lifting means the load is moving upward. So there is a motion also. So in this case also both conditions are satisfying. Let's look at option C, a heavy load hanging from a strong bar. So a heavy load hanging. In order to hang a heavy load, definitely there must be a force acting, but it's simply hanging. It's not moving. So it only satisfies first condition. The displacement of this load is simply zero. It's not moving. It's simply hanging. That means in option C, it does not satisfy the second condition for a work done. Therefore, in option C, work is not done. Therefore, the correct answer is option C, which is the option in which no work being done. Anyway, we can look at the option D, a student dragging. Dragging means definitely it's moving a big box over a rough floor, and rough floor means there must be a frictional force. The student should act a force to overcome the friction. So definitely the student is acting a force and it is displacing as it is dragging. Displacement is also there. So in option D, clearly a work has been done. So only correct answer is option C. Question 10. A student suggests that there are several ways of transferring energy to a small stationary block of iron on a smooth table. He makes the following suggestions. Heat it, shine the light on it, pass a current through it. Which suggestions are correct? So we need to check, in order to transfer energy to a stationary block of iron, which all ways are correct? Out of this given 3 suggestions, which all suggestions are correct or shows the ways to transfer energy to a stationary block? So we can check each options. The first option is by heating the block we can transfer energy to the block, and that is very clear. That is correct, because when we heat any object, heat energy or thermal energy transfers to the block. So first suggestion is correct. Let's look at the second suggestion, shine light on it. That means we have an iron block. Let it be the iron block, and we are shining the light on it. So the lights will fall on these iron blocks. So when the lights falls on the iron blocks, the energy in light will transfer to the iron blocks. So we should know that light is a form of energy. light energy, and this light energy will transfer to the electrons in the iron block, so that the energy of the iron block will increase. So by shining the light on it, light energy can transfer, or actually it is called photon, that you will study in higher grades, the energy of the light. So now you just need to know light is also a kind of energy resource, energy, a type of energy, and this light energy can transfer from one object to another object. Option 3, pass a current through it. Definitely we know that current means electrical energy. So when current passing through the iron, the electrons in the iron will get energy. So all these three ways are correct. Therefore, the correct answer is option D. Question 11. An engine produces 240 kilojoule of energy in 2 minutes. So time and energy is provided. What is the power output of the engine? We need to calculate power. So the equation of power is rate of change of energy, or rate of change of work done. That is P is equal to E over T. This is another equation you have to by heart. From the chapter work, energy, power, we are provided with energy and time. So we can substitute these values. When you look at the options, we can see in options also kilo is given. So we don't need to convert kilo given in the energy. That means the energy value is 240 kilojoule, where this kilo we don't have to convert when we are substituting in the equation, as in the all options kilo is written same like kilo. So we can keep same like that. No need for conversion. If we convert, we will have to convert back. So the energy is 240. I am simply writing kilo itself. Joule over time is 2 minutes. So we have to convert minute into second. So it will be 60. We should multiply minutes with 60. So we will get in seconds. And the answer is 2 kilowatt. The unit of power is watt. So correct answer is option A. Question number 12. A book has a mass of 400 grams. So the mass is provided. The surface of the book in contact with a table has dimensions 0.10 meter and 0.20 meter. So the length of the table and breadth of the table which has contact with the book is given. The gravitational field strength G is 10 Newton per kg. What is the pressure exerted on the table due to the book? So we need to calculate pressure. We can use the equation of pressure, that is force over area. So in this question we have a table, and on the table a book is in contact. So a book has kept on the table. So we need to check what is the pressure acting on this table by this book. For that we can use the equation. The pressure will be the force acting on the table by the book by the area of contact of the book and table. So first we can check what is the force acting on the table by the book. That is nothing but weight of the book, and weight, so we can rewrite the equation. Force exerted by the book is nothing but weight of the book over area in contact, where force equation, weight equation, we know that W is equal to mg. So we can write instead of W it is mg over area equation is length times breadth. So we can understand pressure will be mg, that is the weight of the book, over area, that is length into breadth. Now we can substitute the values. Mass of the book is given, that is 400 gram. So we need to convert gram into kilogram by multiplying with 10 to the power minus 3. This conversion is very important because the mass is given in gram, but when we substituting in an equation, we should change the unit into standard unit, and standard unit of mass is kilogram. So in order to convert gram to kilogram, we need to multiply with 10 to the power minus 3. So the mass, which is 400 gram, I am multiplying with 10 to the power minus 3. Now this is in kilogram times G value is given 10. So we can write 10 over length is 0.10 times breadth is 0.20. We can substitute the values. So we can do the calculation and we will get 200. As pressure unit, there are not Pascal. Pascal is the unit, but that is not given in the option. So we can look at the equation again. We can understand pressure is force over area. So from this we can identify the other unit of pressure, that is force over area. So the unit of force is Newton over unit of area is meter square. So this is the other unit of pressure. So our answer is 200 Newton per meter square. Therefore correct answer is option D. Question 13. The diagram shows a mercury barometer. At which point is the pressure greater than atmospheric pressure? So in this picture we can see at these surfaces it is open to the atmosphere, so that the atmosphere pressure will act on the surface where it is open. So this point represents the level of atmospheric pressure. So when we look at the points A, B, we can see these 2 points are lying above the level of atmospheric pressure. That means the pressure at the top points will be less than the atmospheric pressure. That's why they are staying at the top position. So here the pressure must be less comparing to the atmospheric pressure. Even at this point also pressure will be less. Or we can write the comparing to ATM, the pressure will be less. Or comparing to the atmospheric pressure at these 2 points, the pressure will be less. But when we look at the option C, we can see that C is a point which lies exactly at the level of atmospheric pressure. From this we can understand the pressure at C must be equal to the pressure of atmospheric pressure. Now option D or the position D is lower than the level of atmospheric pressure. That means the pressure of D must be greater than the atmospheric pressure. So we need to identify at which point the pressure greater than the atmospheric pressure. So we have already seen only at point D, as it lies below the level of atmospheric pressure, it will have more pressure. Therefore the correct answer is option D. Question number 14. The table gives information about molecules. Which row describes a gas? So when we consider gas molecules, we know that the particles or molecules are far apart and the force between them is very less comparing to other states like liquid or solid. So the force between the molecules are very less. Therefore they move far apart. So there will be more distance between the gas molecules, as you can see. There will be big separation. So now we can look at the options, and first point about force between molecules, and we already discussed that it will be very much negligible comparing to the other states. So option C or D must be correct. But about the distance between the molecules, we have seen they will be far apart. Therefore the only correct answer is option C, which says the force between the molecules in gas will be less. Therefore the distance between the molecules will be big, or they will be far apart. Question 15. Very small pollen grains are suspended in water. A bright light shines from the side. When looked through a microscope, small specks of light are seen to be moving in random jerky manner. What are the moving specks of light? So this question is about Brownian motion. So through microscope, if we look, we can see the pollen grains moving. We cannot see molecules of the liquid. That is the most important point you should know. Even though we are using through microscope, we can't see the molecules as their size is too small. We can't see molecules. We can see only pollen grains. Can be seen. It is because the size of the pollen grain are much greater comparing to the size of the molecules, so that we can see them with the help of this arrangement. So in this question, he can see small specks of light are seen, means that is nothing but pollen grains. So we have to identify what are the moving specks of light. Pollen grains being hit by pollen grains. So we already discussed these particles which is moving, he can see is pollen grains, not the molecules of the liquid, as molecules of the liquid are too small to see even through microscope. So they are pollen grains. But why these pollen grains are moving in a zigzag manner? It is because the small molecules inside this liquid, even though which we cannot see through the microscope, they are there and they will be moving in random direction with very high speed. So the molecules in the liquid will be moving randomly with high speed, will hit the pollen grains. So because of these pollen grains are moving in random direction. So the reason is these pollen grains are being hit by randomly moving liquid molecules with very high speed. They hit the pollen grains, so that the pollen grains also moving in random direction. So we can conclude, we can see only pollen grains but being hit by not other pollen grains but other water molecules. So pollen grains being hit by water molecules is the correct answer. Option C says he can see the water molecules, but that is wrong. Water molecules are too small, so we can't even see through a microscope. So the water molecules, this is wrong. And here these all other pollen grains are hitting, that is also wrong. So the correct answer is option B. Question 16. Why are small gaps left between the metal rails of the railway track? So when metal rails fix on the tracks, a small gap leave between these metal rails. And what is the purpose of leaving these small gaps? The reason is due to thermal expansion. What is thermal expansion? When the temperature increases, molecules will gain more energy, so they will move quicker, so that the space between them will increase, so that object will expand. So thermal expansion means at hot temperature, molecules move faster as they gain more energy in the form of thermal energy. So when the molecule moves faster, space between the molecule increase. So when the space between the molecule increase, definitely that object will expand, or that material will expand. So this is what called thermal expansion. So this will be applicable for the rail tracks also. The metal rails at hot weather or at summer, they will expand. So there should be enough space to expand. That's why we are leaving some spaces. Now we can look at the options. Option A says to allow for expansion for the rails on hot day. That is correct. We have already discussed for the expansion and which will happen in hot days. We can see other options. Option B says to allow for contraction on hot day. On hot day, it will only expand, no contraction. Option C says for the expansion on a cold day. On a cold day, it will contract, not expand. Option D says to allow for contraction of the rail on cold day. The statement is correct that on cold day, it will contract. But leaving space means we are thinking about the expansion. When it expands, there should be enough space. That's why leaving space. So the correct answer is option A. A block of metal absorbs 2000 joule of thermal energy. The temperature of the block rises from 10 degrees Celsius to 20 degrees Celsius. The mass of the block is 22 kilogram. What is the specific heat capacity of the metal? So we are provided with the energy and temperature before and after. So we can find from this the change in temperature delta theta by subtracting 20 degrees Celsius and 10 degrees Celsius. So we will get the change in temperature is 10 degrees Celsius. Mass of the block is also given. We need to calculate specific heat capacity C. So we can use the equation which relate all these terms, that is the energy required E, or you can use the symbol Q to represent temperature. Thermal energy Q is the product of the mass of the substance times the specific heat capacity of the substance times change in temperature delta theta, or change in temperature delta T. Here I will use the symbol delta T to represent change in temperature. In order to calculate specific heat capacity C, we can make C as the subject of the equation. So we will get C is equal to, keeping C at the same space and take the everything else to the other side. So we will get thermal energy Q over M delta T will come to the denominator. We can substitute the value 2000 over mass is 2 times change in temperature we have calculated 10 degree, and the answer is 100. Therefore the correct answer is option B. Question 18. Which statement about boiling and evaporation is correct? Boiling requires a supply of thermal energy but evaporation does not. This statement is wrong because both evaporation and boiling require thermal energy. If there is some energy in the form of temperature, then only the molecules gain energy and they will escape. But for boiling, the thermal energy required is very high, that is 100 degrees Celsius or even more than that. But evaporation, it is not as high as boiling. But still for evaporation also it requires some thermal energy. So option A is wrong. Let's see option B. Evaporation takes place at the surface of the liquid, but boiling takes place through the liquid. That is a correct statement, because we know that if you keep some liquid in an open container, what is actually happening in the process of evaporation is the molecules which are staying at the surface of the liquid will gain or absorb thermal energy from the atmosphere and they will escape. So evaporation actually happening only to the molecules, they are staying at the surface of the liquid. That's why it's called a surface phenomena. But when we boil a liquid by supplying a very high temperature, what happened? The whole liquid get high energy and all molecules starts to vibrate and they will escape. So boiling takes place throughout the liquid, but the evaporation takes place only at the surface of the liquid. Anyway, we can see the other options. Option C says when water boils in a kettle, its temperature decreases. No, we have already seen how the boiling happens. We need to keep supplying very high thermal energy. So the temperature is never going to decrease, but it will keep increasing. Therefore, option C is wrong. Option D says when water evaporates, its temperature increases. That is also wrong, because when the molecule escape, the high temperature molecules are escaping, or high energy molecules are escaping. So the average temperature of the liquid will drop. So instead of increases, it decreases. The remaining liquid temperature will decrease. So the only correct answer is option B. Question 19. A metal rod is heated at end X. What does end Y of the metal rod become hot? Why does end Y of the metal rod becomes hot? So here we need to know clearly about conduction, the way how heat transfers in solids. If the metal rod is heated at the end of X, here you are applying thermal energy. This thermal energy will transfer to the other end. But how? This is the question. So basically this is due to the process of conduction. A way of thermal energy transferring in solids. And this will happen with two different ways. The first one is the vibration of the ions or molecules. So here we should know the ions or the molecules, they will be close to each other. They cannot move from one place to another place. But when you supply heat energy to the one end, these ions starts to vibrate. So this vibration will transfer or make the neighboring ions to vibrate. So like this vibration will continue or transfer or move from one end to another end. This is how the heat energy will transfer. So here one important point, here the ions or molecules are not moving, but they are vibrating, and this vibration is affecting the neighboring ions also to vibrate, so that this vibration is only transferring. So that is the one way in conduction, the heat transfer, vibration of ions. And the second way is the free electrons available in this rod or metal rod. They are free to move. They are not fixed as ions or molecules. They are out of the atoms and they can freely move. So the movement of electrons. This means if you have a metal rod and if you heat at one end, the free electrons available next to this space where you applied heat, they will gain more energy and they will move to the other side of the metal, so that these electrons with high temperature will reach the other side. This is the second way in conduction, the heat transfer. Now let's read the options. Option A says energy is transferred from end X of the rod to the end Y by vibration of positive ions. This is correct, which we have discussed, and by movement of electrons. These both ways are correct. So therefore the correct answer is option A. In option B, it says that the movement of positive ions or molecules, they cannot move, they will be staying at the fixed place. Option C says the vibration of Vibration of positive charge only. That is wrong. Because we know that there are two methods. One is vibration of positive charged ion and second method is also there. That is a movement of electrons. So that is not mentioned here. Therefore option C is wrong. Option D says energy is transferred from end of X of the rod to end of Y by movement of electrons only. That is also wrong. Not only with the movement of electron but with the vibration of positive ions also the heat transfer is possible in the process of conduction. So the correct answer is option A. Question 20. Two square sheets of metal P and Q are heated to the same temperature. The metal sheets are shown. Sheet Q is emitting more radiation than sheet P. Which statement explains this? So here the important point given in the question is sheet Q emitting more radiation than sheet P. So here we have to think about the emission. And in the first statement of the question it says that both the sheets heated to the same temperature. So both of the sheet are having same temperature inside it, but in terms of emission of heat to the surrounding is greater for sheet Q comparing to sheet P. So when we look at the emission of P, which is less, only this much, but even though the sheet Q has the same temperature, it emits more. So we can check what are the factors affecting the emission of thermal energy or emission of heat from a surface. The first point is its temperature. When the temperature of an object is more, it will emit more thermal energy. So the temperature is a factor which decides the amount of emission. But in this question we know both sheets are having same amount of temperature. That means the temperature we can't check or we cannot look at the temperature. Is it because of the temperature sheet Q is emitting more? No, both of the sheets are having same temperature. The second factor which affect the emission is surface area. When the surface area is more, definitely the emission will be more. So by looking at these two sheets we can understand, yes, Q has more subsurface area. That means definitely it will have more emission. And the third point is about the material and the dull black comparing to white surfaces will emit more. Here the sheet P is dull black, so it will emit more depending on its material property comparing to Q, but as the surface area is much more comparing to P, using this property the emission will be more for Q. Now we can see the options. Option A says dull black surfaces are better conductors of radiation. That is correct, but better conductors of radiation doesn't give a justification about why sheet Q emits. It's all this statement only mention about conduction, but we need to know about emission because in the question it's mentioned about emission. So about emission we cannot get any clue from option A. But option B says dull black surfaces are better emitters of radiation. But the sheet Q is not made of dull black. So that is not the explanation for this conclusion. Therefore option B is also not correct. Option C says the surface area of Q is larger than P. Yes, that is correct. We can see the surface area of Q is very much greater than P, and we already discussed when the surface area is more, emission will be more. So definitely that is the reason for this particular example Q emits more radiation. So correct answer is option C. Option D says white surfaces are better absorbers of radiation. Again here they are mentioning about absorption, not about emission. but we need to give the explanation for why Q emits more. Only explain about the emission. So the correct answer is only option C. Question 21. A water wave passes into a region where the wave travels more slowly. As it passes into slow region, what happens to the frequency and what happens to the wavelength of a wave? So it's as already mentioned, when the wave passes to slow region, that means the velocity will decrease. What happens to the frequency and what happens to the wavelength? So first we can think about frequency. We need to know that for a water wave, frequency is decided by the source which produces the wave. That means how many waves that source produce, that is frequency, or how many waves produce in 1 second, that is frequency, and which is only depending on the source. Source of water wave, doesn't matter the water speed is more or less, it's not going to affect the frequency. So that we can conclude that the frequency will remain same throughout the motion. Doesn't matter speed is greater or lesser. Next, about wavelength. What will happen to wavelength when the speed decreases? To check that, we should use the equation, wave equation, that is speed of a wave is the product of its frequency and wavelength. And we have already seen frequency will remain same. But in this particular case, the velocity decreasing. And in order to maintain the frequency same, definitely the wavelength of the wave will reduce. So now we can check which option is correct. As we have already discussed, the frequency will remain same. So it will be either option C or D. And we have already seen that the wavelength will decrease. So the correct answer is option C. Question 22. Light traveling at a speed of 3 × 10⁸ meter per second strikes the surface of a glass block and undergoes refraction as it enters the block. The diagram shows a ray of this light before and after it enters the block. So we are provided with the angle of incidence and angle of reflection. We need to calculate what is the speed of light in glass. So in order to find the speed of light in the glass, I am representing it with Vg, speed of light in glass. We can use the equation of refractive index. That is, refractive index is the ratio of the speed of light in air or vacuum divided by speed of light in that medium. Here we have glass. So this is the refractive index equation. And there is another equation for refractive index, that is M refractive index is sine of the angle of incidence over sine of angle of refraction. So both are the equation of refractive index. So we can equate the RHS of both the equations. So we will get speed of light in vacuum over speed of light in glass will be is equal to sine of angle of incidence over sine of angle of refraction. So in this question we are provided with the speed of light in the air is given, I is given, angle of incidence and angle of refraction is given. So we can substitute. So just substitute the value. C is 3 × 10⁸ over speed of light in glass is equal to sine 55 over sine R. So therefore 3 × 10⁸ over Vg, sine 55 over sine R is 33. So when you substitute, you will get this is 1.5. In order to calculate Vg, make Vg as the subject, or you can take Vg to the right hand side and take 1.5 to the left hand side. So you will get Vg is 3 into 10 to the power 8 over 1.5. So the correct answer is 2 times 10 to the power 8 meter per second. Therefore, the correct answer is option B. Question 23. The diagram shows a narrow beam of light incident on a glass air boundary. Some of the light emerges along the surface of the glass and some is reflected back into the glass. So here we have a beam of light falling on the surface of a glass air boundary. Out of this beam, some of the light emerges along the surface as shown in the figure and some is reflected back. Which row is correct? Option A. This is an example of total internal reflection. That is wrong. If it is a total internal reflection means all the rays which are falling on a boundary will reflect back. Totally all rays will reflect back. That's why it's called total internal reflection. But here we can see only few of the rays are reflecting. Remaining all are passing through the boundary. So this is not an example of total internal reflection. Therefore, no is correct. It's not an example of a total internal reflection because here only few rays are reflecting. Not all the rays are reflecting. Option A, second column, angle theta is critical angle. So let's see this angle theta. If this is a critical angle, what is the condition or property of a critical angle? When a ray falls at critical angle, its rays will pass through the boundary. So we can see some of the rays are passing through the boundary. That means the ray must incident at critical angle. So definitely the angle given or the theta must be a critical angle, then only the few of the rays can pass through this boundary. Therefore, the correct answer is option A. Question 24. An object is placed in front of a thin converging lens. The diagram shows the path of two rays from the top of the object. An image of the object is formed on the screen to the right of the lens. How does this image compare with the object? So in order to check the property of the image formed from this diagram, we need to extend these rays. So you need to take a ruler and first extend this ray. Using a ruler, it should be straight line. Likewise, we can extend the other ray, the ray which is passing through the center of the lens, which won't deviate but this will move straight. So any ray which is passing through the center of the lens will always move straight without any diffraction or deviation. So we can complete the second row by extending it with a ruler as a straight line. So these are two rays. The path of two rays, when we extend, we can see, and we can check where these points, two rays are meeting. This is the point where two rays are meeting. Here the image will be formed. So we can just draw a straight line from the principal axis. So this will be the position and the size of the image, and its direction is downward or inverted. So the image of the object will be formed here. Now we can check the characteristics of the image. Comparing to the size of the object, the image is larger. So that is the first point. Image formed is larger. And the second point, it is inverted. As you can see, the object is upright but the image is inverted. So that is the second property, that is inverted. The image is inverted. Now we can see the options. Option A says the image is larger and inverted. That is true. Therefore, correct answer is option A. Anyway, we can see other options. Option B says it is larger. That is correct. And the same way up. No, it is inverted, upside down. So option B is wrong. Option C says it is smaller and inverted. It is inverted, but it is larger, not smaller. Option D says it is smaller. Again, that is wrong. And the same way up. Both the points about option D is wrong. Therefore, correct answer is option A. Question 25. A remote controlled vehicle is traveling on the surface of a planet. The vehicle senses an obstacle ahead. It sends a radio message to the control room from where it is being controlled. The control room is 2.4 into 10 to the power 6 km away from the vehicle. The control room sends a message back to the vehicle telling it to stop. What is the minimum time that elapses between the vehicle sensing the obstacle and receiving the message back from the control room? So we have a vehicle. So let this be the vehicle and a control room. Control room is, let this be the control room. The distance between the vehicle and the control room is 2.4 times 10 to the power 6 km. So we need to check or calculate what will be the time taken by a signal when it sends from the vehicle to the control station and receive it back. So here we have to calculate the time taken by the signal to travel from vehicles to the control station and back from the control station to vehicle. So the total distance traveled is 2 times 2 to the power 4 into 10 to the power 6 kilometers, because the signal has to reach from vehicle to control station and it should come back. So the total distance will be double the distance between vehicle to control station. Now we have the distance covered and even we know the speed of the signal. Here we have to use only electromagnetic waves, because electromagnetic waves are the only wave which can transfer through the space. So the speed of electromagnetic wave is speed of light, that is 3 into 10 to the power 8 meter per second. So we have distance, we have speed. So if we have distance and speed, we can calculate the time taken using the equation distance is equal to speed into time, or it is basically from the equation speed is distance over time. From this, in order to calculate time, we can make time as the subject. So we will get time is equal to distance over speed. We have the values, we can substitute, that is time is equal to, the distance is 2 times 2 to the 2.4 times 10 to the power 6 kilometer. So we need to convert kilometer to meter. So for kilometer to meter conversion, we should multiply with the 10 to the power 3. So that conversion also we have to do here. Now we have converted from kilometer to meter by multiplying with 10 to the power 3 over speed of this electromagnetic wave, which is 3 into 10 to the power 8. And the answer is 16. Therefore, 16 seconds. Correct answer is option D. So this is a simple question where you have to use the equation of speed, that is distance over time, and in order to calculate time you can rearrange. So you will get time is distance over speed. Question 26. A sound wave is traveling outwards from a loudspeaker into the surrounding air. Here are 3 statements. The air pressure is lower at the rarefaction compared with undisturbed air. Second statement, the density of the air is less at a compression compared with undisturbed air. Third statement, the distance from a compression to a rarefaction equals half a wavelength. Let us look at the Characteristic of a sound wave. A sound wave consists of compressions, these particles where these spaces where the particles of the air are compressed together, that is known as compressions. When you look at the picture, you can see some places the particles are more close together, and these places are known as compressions. And even you can see there are some spaces where the particles are far apart, and these places are known as rarefaction. So we have compressions and rarefactions in a sound wave. And there are spaces in between and compressions and rarefactions. There we can say undisturbed air, or there the density will be normal, which will be greater than the, or the pressure will be greater than the rarefactions but greater than the compressions. So in first statement it says the same thing. The pressure is lower at rarefaction. Yes, the pressure will be lowest always at rarefaction compared with the undisturbed air or most disturbed air, that is compression region. So the first statement is correct. Second statement says that the density of air is less at compression compared with undisturbed air. But when we look at the picture itself, we can understand. Look at the compression regions where you can see the particles are more closely bound, right? Particles are staying more close together. That means there the density must be greater, because number of particles are more in the same space or same volume. So always the density of air is more in compression. So option 2 or the statement 2 is wrong. Now statement 3 states that the distance from a compression to a rarefaction equals to the half the wavelength. So you can even see the compressions and rarefactions we can express as a wave in this way. So here we can see a wavelength is the distance of one complete wave, that is lambda. So now we can see, as mentioned in this third statement, the distance between the compression and rarefaction. So this is the first compression, and to a rarefaction equals half a wavelength. So we can see first of all where we will get half wavelength. This part is represent half wavelength, half of the wave. So the starting is compression, and the ending part of this half wavelength, when we extend, we can see this is a rarefaction. So the distance between this is half lambda. So that the third statement is also correct. So option B, that is 1 and 3 statements are correct. Question 27. The sound from a loudspeaker must pass through two materials to reach a microphone. Which combination of material gives the sound shortest time for the sound to reach the microphone? So we need to check which combination of materials will allow the sound wave to pass faster. So here we need to find through which material the sound can travel faster. So we have the options here: air, liquid, that is water is a liquid, and solid. Copper and aluminium belongs to solid. So when we check the speed of sound, which is most in solid, so we can understand velocity or speed of sound in solid is very high. Then the speed or velocity of sound in liquid, and the least speed the sound will have in air. So the velocity of the sound in air is least. So when we see the options, we can see copper and aluminium both are solids, so the sound will travel faster if we use these two metals or material 1 and 2. Therefore the correct answer is option C. Question 28. Diagram 1 shows a small compass needle with its poles marked. It is not near any magnetic material. Diagram 2 shows a bar magnet with its poles marked. The compass needle is placed at point P. So we need to check in which direction will north pole of the compass needle points. When we keep this compass at point P, what will happen to this compass needle? Where, in which direction the north pole will direct? In order to check that, we have to draw the magnetic field line of this bar magnet which is passing through the point P. So it must be like this, and which will direct from north pole to the south pole. So this will be the direction. Now when we keep this compass here, the north side of this arrow will point towards the south and in the same direction of the magnetic field line. So we can see the magnetic field line at the center or at this point is parallel to the bar, and which will definitely point towards south pole of the bar magnet. Therefore, we can conclude that the north pole of the compass needle point to the right, as shown in this diagram. The correct answer is option B, to the right. Question 29. A student rubs a plastic rod with a cloth. The rod becomes positively charged. What has happened to the rod? So we have a plastic rod. When it rubbed with a cloth, it becomes positively charged. That means it must have lost some electrons, because protons that have positive charge cannot move from an atom. So the protons cannot move, but only electrons can move. So as this rod has become positive charge, means it must have lost some electrons or negatively charged particle, that is electron. So because of this loss of electrons from the rod, definitely the rod will become positive charge. So this is what happens. Any object which becomes positively charged means it has lost some negatively charged electrons. Let's see the options. Option A says it has gained electrons. If the rod has gained electrons, then the rod will become negative charge. But here the rod become positive charge. That means option A is wrong. Option B says it gained protons. I already mentioned the protons cannot move from one object to another object because they are bound inside the nucleus. They cannot move outside. So never protons are going to gain or lose. So this is also wrong. Option C says it has lost electron. That is correct. The electrons can move from one object to another object. So the rod has lost electron. So the total charge of the rod will become positive. Option D says it has lost proton. As we have already discussed, protons can neither gain nor lost. It can stay only in the same place. Therefore, the correct answer is option C. Question 30. An isolated metal sphere is positively charged. It is then brought near to another isolated metal sphere that is neutral. What happens to the charges on the neutral sphere as the positively charged sphere is brought close to it? So when this positively charged sphere bring close to the neutral metal sphere, initially the metal sphere will have equal number of protons and equal number of electrons. But when this positively charged sphere comes close to this neutral metal sphere, all the electrons in the metal sphere or the neutral metal sphere will come close to the positive charge because electrons can move freely. So electrons present at the right side of the sphere will also come to the left side of the sphere, but proton will stay in the same place. But you can see the electrons will move towards the left, that is close to the positive charged sphere, as the electrostatic force of attraction between opposite charges. This is what happens. So we can check the options now. Option A says some positive charges move to the left, but we already discussed positive charges cannot move. Positive charges means these are due to protons, and protons cannot move, they can only reside inside a nucleus. So option A is wrong. Option B, some positive charges move. Again, that is wrong. As we discussed, positive charges will never move. Option C says some positive charges move. Again it is wrong. Option D says the positive charges do not move. Yes, this is a correct statement. But some negative charges move to the left. Right, that is nothing but electrons. The negative charged particles, electrons can move, and all the electrons will move to the left where we have kept the positively charged sphere. So the correct answer is option D. Question 31. Which statement about the resistance of a metal wire is correct? So here we need to know the basic idea or the factors affecting resistance. So the factors which affects the resistance are resistance of a wire. The first one is length. When the length increases, the resistance increases. So the length and the resistance are directly proportional. The second one is area of cross section, and they are inversely proportional. That means when the area of resistance is inversely proportional to area of cross section, that means when the area of cross section of the wire increases, resistance decreases. And the third factor is temperature. When the resistance increases, temperature will also increases. And the fourth factor is material. So some materials will have a property that they will oppose the flow of current. So they will have a high resistance. So here in these options we can see which one gives a correct answer. So option A says the resistance is directly proportional to length. Yes, which we have seen in our first option. Length is directly proportional to resistance. And it says is directly proportional to cross-sectional area. It is not directly proportional to cross-sectional area. Resistance is inversely proportional to cross-sectional area. So option A is wrong. Option B says the resistance is directly proportional to its length and inversely proportional to its cross-sectional area. So option B is correct. We can check option C and D. Option C says the resistance is inversely proportional. That is wrong. Resistance is directly proportional. Even in option D also it says the resistance is inversely proportional to the length. So the correct answer is option B. Question 32. The circuit diagram shows a light dependent resistor in a potential divider. A voltmeter is connected across the light dependent resistor or LDR. Which row shows the resistance of LDR and the potential difference shown on the voltmeter at a specific light level? So in this question we are provided with a potential divider. In this potential divider, one resistor is light dependent resistor and there is a voltmeter connected across this light dependent resistor. We need to check at different light levels what will happen to the resistance of the LDR and the reading on the voltmeter. Which row shows the correct answers? So first of all we can look at the circuit diagram and let's check the property of a potential divider circuit and an LDR. So initially we need to focus on the LDR. What is LDR and how it works? So LDR or light dependent resistor, as the name indicates, it is a resistor. But its resistance value is not constant always. It changes. It changes depending upon the light intensity or light falling on it. So when the light falling on it increases, or the brightness or the light intensity increases, its resistance will decrease. So the relation is when light intensity, or that is nothing but brightness, when the brightness of the light falling on it increases, the resistance of LDR will decrease. So for this particular LDR, imagine lots of light waves are falling, or the light which is falling on this LDR is having lots of intensity, light intensity or brightness. In that case, the resistance will drop. So we can see if we have same LDR, but the light falling is, or the light intensity falling on this LDR is less. See, only few light waves are falling. So in this case, as the brightness is less, brightness or the light intensity is less, the resistance will be more. So this is the property of LDR. So for example, for this particular light intensity, if the resistance is 100 ohm, when the brightness of light falling on it reduces, as a result the resistance will increase. So now we will have the same LDR, but its resistance will increase. So this is the property of the LDR you must know. Next we can see how a potential divider circuit works. This combination of two resistors in series act as a potential divider circuit. So now we can see the property of a potential divider circuit. So we have two resistors connected in series is known as, or it can be act as a potential divider. Now we are going to connect a voltmeter across second resistor. So this voltmeter will read the resistance across second resistor. So let the first resistor is R1 and the second resistor is R2. Now we can see when this resistor R2 value increases, what will happen to the voltmeter reading? Will it increase or decrease? So this is something very important about potential divider circuit. That is the resistance across the voltmeter. Here R2 is the resistance we have connected across the voltmeter. When this resistor value increases, the voltage across this resistance will increase, so that the voltmeter reading will increase. So this is something very important point, that whenever the resistance increases, the voltage drop across that resistance will increase. Or if the resistance across R2 decreases, the voltage drop across that component or the reading on the voltmeter will reduce. So this is something you should know about a potential divider circuit. Potential divider circuit means nothing but you are connecting two resistors in series. So if you know these two properties, we can check what will be the correct option. So let's look at the options. Option A says the light level or the brightness of the light falling on this LDR is dim or bright. It says when the light level is bright, that means the higher intensity light is falling. This is the situation where brightness is high. So we can see what will happen to the resistance. We already seen the resistance will be less when the brightness is more. So that one is correct. In the option also it says when the brightness of light falling on the LDR is more, its resistance will drop. So the resistance of the LDR will be less. That is correct, as we have already learned the property of an LDR. Now we can see at that time what will happen to the voltmeter reading. As the resistance is reduced, what will be the voltage reading across that resistance? So we can look at the potential divider circuit. As the resistance reduced, the voltage must reduce. But here the voltmeter reading is not reduced but it is high. Therefore option A is wrong. Now we can see option B. Again the light level is bright. So we already seen when the light falling on the LDR is more, or the brightness is more, or the intensity is more, the resistance will be less, right? When the brightness or the light intensity falling on the LDR increases, the resistance will drop. But here it says that in this case the resistance will increase. That is wrong. Therefore option B is not correct. Now let's see option C. In option C it says the light level is dim. So we can see when the light is dim or its brightness is less, we have seen the resistance will be great or resistance will be more. So here in option C it says when the light level is dim or less, the resistance will be high. Yes, that is correct, because we have seen when the brightness is more, the resistance will be high. So that part is correct. Now we can see what will happen to the PD shown on the voltmeter or the reading on the voltmeter. As the resistance is high, the voltmeter reading will also be high. So here it says the voltmeter reading or the potential difference showing on the voltmeter will be high. So that is also correct. Therefore the correct answer is option C. In order to answer this question, you must be knowing the property of an LDR and how a potential divider circuit works. Let's go to question 33. 3 NAND gates are connected in a single chip as shown. The whole chip behaves as a single logic gate. Which type of logic gate does the chip act as? So we have a chip in which 3 logic gates connected, 3 NAND gates connected as shown in this figure. When we give different inputs, what will be the output of this particular logic gate combination? Let's check that first. So we have 2 inputs, input 1 and input 2, and 1 output. So we can see what will be the output for different possible input combinations. So the possible input combinations are 0 0, 0 1, 1 0 and 1 1. Now we can focus on the first input combination. When the inputs both are 0 0, what will be the output? We can check that. So the input at 1 is 0 and input at 2 is also 0. In this case, what will be the output? In order to know that, we should know what is the truth table of a NAND gate. So for a truth table of NAND gate, the possible inputs we can see. Again, always the possible inputs will be in this way, 0 0 0 1, 1 0 and 1 1. In this case, the output of a NAND gate is 1 1 1 0. So with the help of the truth table of NAND gate, we can find what will be the output of this whole logic gate combinations. So we can start with the possible inputs. That first one 0 0. When 0 0 is the input, we know that the output will be 0. So here for both input, as the 0 is connecting to both the inputs, both inputs of the first NAND gate will be 0. As a result, the output of first NAND gate will be 1. Likewise for input 2 also we have connected 0. So the 0 will be connecting to both input terminals. So both input terminal it will be 0 0. And with the help of NAND gate truth table we can understand when the inputs are 0 0, the output will be 1. So this 1 we are connecting to the input of the third NAND gate. So for third NAND gate, the initial input is 1 and 1. In this case, what will be the output? When the inputs are 1 and 1, output of a NAND gate will be 0. So here the output will be 0. So for this whole combination of logic gate, when the inputs are 0, 0, we have already seen the output will be 0. So that is the first possible combination. Now we can see what will be the output for the second possible input combination, that is for 0, 1. What will be the output? So let's see, we have the first input value 0, at second input we have 1. So as we are connecting 0 to the first NAND gate, at both input will be 0, 0. Likewise 1 will be at both the input of second NAND gate. So here we will have 1, 1. We can see what will be the output for this corresponding NAND gates. When both inputs are 0, 0, the output will be 1. So here the output will be 1 for the first NAND gate. Likewise, when both inputs are 1, 1, the output will be 0. So for the second NAND gate, the output will be 0. So for the third NAND gate, we have one input as 0 and one input as 0. Sorry, one input as 1 and the second input as 0. In this case, we can see what is the output combination. For a NAND gate, when the input is 1, 0, then the output will be 1. So for this second combination, the output will be 1. Therefore, we can write the output when the inputs are 0 and 1 for this combination of logic gates, the output will be 1. Now we can focus on the third possible input combination, that is 1 at one input terminal and 0 at another input terminal. So for the first input it must be 1 and for second input it should be 0. So for first input, as 1 is connecting at both ends, it will be 1, and at both inputs it will be 0 for the second input. So we can see when the inputs are both 1 for a NAND gate, the output will be 0. Therefore, here the output for the first NAND gate will be 0. Likewise, we can see when both the inputs are 0, 0, what will be the output of a NAND gate? That will be 1. So here it will be 1. Now we can focus on the third NAND gate in this logic gate, where we have input 0 and 1. So now again we can focus on the NAND gate, where if you have 0, 1 input, the output will be 1. So for this 0, 1 input combination, we will get 1 as the output. Therefore, for this 1, 0 combination for the whole logic gate, we will get 1 as the output. Finally, we can look at the last input combination where both the inputs are 1 and 1. What will happen? So the input 1 is 1 and input 2 is also 1. In this case, at both the inputs for both logic gate, the inputs are 1, 1. In this case, the output of a NAND gate will be 0. So as a result, we will get 0 as the output for both the NAND gate 1 and 2. And as we are connecting this to the third NAND gate, the inputs of third NAND gate is 0, 0. In this input combination, when the inputs are 0, 0, the output will be 1. So here the output will be 1. So we can understand that when the inputs both are 0, 0, we will get output also, when the input both are 1, 1, we will get output also 1. So this is the truth table of this particular combination of logic gates. Now we need to check this truth table is similar to which logic gate. So is it similar to a truth table of an AND logic gate, or the truth table of NAND, or truth table of NOR, or OR? So if you know the truth table of OR for different input combination, what will be the output? So when we focusing on the OR truth table, we can see for 0, 0, 0, 1, 1, 0, 1, 1 in possible input combination, the output is 0, 1, 1, 1. And now we can relate This truth table is same as this one. Therefore, the given combination of logic gates in the question is similar to the truth table of a OR gate, or it works same as an OR gate. Therefore, correct answer is option D. Question 34. A solenoid is connected to a very sensitive ammeter. A rod is inserted into one end of the solenoid. The ammeter shows that there is a small electric current in the solenoid while the rod is moving. Which rod is being inserted? So actually, when the rod is inserting into this solenoid, in order to have a reading on the ammeter, there must be a current produced when the rod is inserting. That means there must be a induced EMF generate while the rod is inserting. So this is an example of electromagnetic induction. Or we can understand that when the rod is inserting, as the ammeter is showing some reading, there must be electricity generating. It is only because of the process of electromagnetic induction. So electromagnetic induction is happening here. Now, in order to occur an electromagnetic induction, what material this rod should be made of? So we know that electromagnetic induction is a property in which the electricity generates when the magnetic field lines are cutting off. In order to have this rod must be a magnet. If it is a magnet only, when it inserts inside the solenoid, its field lines will get cut. As a result, there will be a induced EMF generate, or there will be a current generating. As a result, the ammeter will show some reading. So the condition for this is the rod must be a piece of magnet. Now we can look at the options. Which option says the rod is a magnet? And we can directly see it's option B, which says the rod is a magnetized steel rod. Then only the field lines will cut when it inserted in the solenoid, and it will produce a current due to the result of electromagnetic induction. Question 35. The diagram shows an electric generator with the coil in a vertical position. Which row describes the generator? The first column says about the generator produces AC or DC current. As we know that the generator will only produce AC currents as its direction is keep changing, or the EMF in every half cycle is keep changing. It will produce a current which will be AC. Therefore option C and option D is wrong. It says it produces DC current. That is not possible with a generator. Next column says about the voltage output will be 0. So when this coil rotates in between these magnetic poles, in order to have a maximum voltage, this coil should cut maximum number of field lines in between these poles. So when there is a maximum cutting happen, it will produce maximum current. But as you can see in the same position, if the coil is the same position as shown, like vertical, both the magnetic field line and coil at this particular point is moving parallel, so that there is no cutting happening. So only at this particular position, for that moment, there is no cutting happening, and the voltage produced at this particular point will be 0 when the coil is positioning exactly as shown in the figure, when the coil is vertical. So when the coil position is at vertical, it is not cutting any field line, so the output voltage will be 0, and this generator will always produce an AC current. Therefore, correct answer is option B. Question 36. The diagram shows a transformer. There are 460 turns on the primary coil and 24 turns on the secondary coil. The primary voltage is 230 volts. What is the secondary voltage? So in this question we are provided with the number of turns in the primary coil, that is Np is 460, and the number of turns in the secondary coil, that is Ns, is 24 turns. Then the primary voltage or the voltage at the primary coil Vp is also given 230. We have to calculate what is the voltage at secondary coil. So Vs we need to calculate. Here we can use the equation of transformer, that is Ns over Np is equal to Vs over Vp. In order to calculate what is the voltage at secondary, we can rearrange the equation. For that, we can take Vp to the LHS of the equation. We can rewrite the equation then Ns over Np, which is already at the LHS of the equation or left hand side of the equation, times the Vp. When it comes to the other side, it will become multiplication, that is equal to Vs. Now we can substitute the values. Ns is 24 over Np is 460 times Vp is 230, and the correct answer is 12 volt. So therefore the correct answer is option B, 12 volt. Question 37. The charge on a proton is E. What is the charge on an electron and what is the charge on a neutron? So we know that a proton has a positive charge and electron negative, but neutron has no charge. So if we represent plus E or simply E, that is a positive E for proton, we can represent negative E for electron. And for neutron, as it has no charge, we can represent as 0. Therefore, option D says these things, that electron will have negative E and neutron will have 0. So the correct answer is option D. Question 38. 4 students are asked to comment on the process of nuclear fission and nuclear fusion. Their comments are recorded in the table. Which row is correct? So in order to answer this, we must be knowing what is nuclear fission and what is nuclear fusion. First of all, we can see what is nuclear fission. Nuclear fission means a heavy nucleus splits into two lighter nucleus. So fission means splitting, or it splits in heavy nucleus, whereas a fusion means two light nucleuses join together and produces a fuse, or join together and produces a heavy nucleus. So here it is joining of two lighter nucleus. That is the process of fusion. Let's look at the options. Option A says energy is absorbed, a large unstable nucleus split. So fission, it says, option A states energy is absorbed. But another important point we need to know that in both the process, whether it is fission or fusion, a large amount of energy is released. Energy always released. Doesn't matter whether it is fission or fusion. In both cases, a large amount of energy will be released. But in the option A, it says the energy is absorbed. That is wrong. We can see option B. In that also, it mentioned about fusion, the energy is absorbed. Even option C also says energy is absorbed. But energy will never absorb, but it will release a large amount of energy in the case of both fission and fusion. So definitely option D will be correct. And we can see option D. In option D, it says fission process. It releases energy. That is correct. And fission means two light nuclei join. Yes, we have already discussed that. The fusion means two light nucleus will join. So that the correct answer is option D. Question 39. Radon decays by emitting alpha particles. Which nuclide is formed in this decay? So we have a radon with its atomic number and mass number is given, and After a decay, it emits an alpha particle. So alpha particle means it is similar to an helium nucleus. So it will have 2 atomic number and 4 mass number. So when from this radon, if it decay a particle with 2 atomic number and 4 mass number, what will happen to the new product? So we can think the new product as X, and we can see what will be its new atomic number and mass number. So from 86, 2 has gone, so the remaining will be 86 minus 2, that will be 84. Likewise, at the mass number, 4 has reduced. So from 219, 4 has reduced or left from the nucleus in the form of alpha particle. So the remaining will be 219 minus 4, that will be 215. So we will get a new product with an atomic number of 84 and mass number of 215. So we can see the options. So it is option A is the correct answer, as its atomic number 84 and mass number 215. Going to question 40. The graph shows the activity of a radioactive source over a period of time. So the activity and time graph is shown. What is the half-life of the source? So what is half-life? Half-life is the time taken to reduce its activity exactly half. So initially its activity is 120. Now the half of 120, that is 60. So we need to check what is the time taken in order to reduce its activity from 120 to 60. So we can look at the graph. Initially this was 120, and when it reaches 60, that is this point represents 60 activity. So in order to change from here to here, what is the total time taken from 120 to 60? So this is the time taken, and that is we clearly seen it is 2 minutes. Therefore the correct answer is 2 minutes. Thank you for watching the video. If you like this video, please subscribe my channel. Thank you.